the rightmost position. I've already used one of the digits at the leftmost position. Out of 10 digits, 2 of the digits have been used. So definitely for the middle position, I'll be left over with only 8 digits. I need to fill the first place and the second place and the third place. So 64 into 4, which is 256, is the correct answer to the second part. So the point is this much simple. We were given with the condition that the units place should be prime. So out here, I can fill any of the 4 digits. I'll be using one of the digit out here. So I cannot use 0 as well as that particular digit, which I'll be writing at the last position out here. So let's say I've used 5. So 0 and 5 cannot turn up here. So out of 10 digits, 2 of the digits are out. So I'll be left over with 8 of the digits here. I've used one of the digit here, one of the digit here. So definitely 2 of the digits have been used already. So at the second position, out of 10 digits, 2 have been used. So I'll be left over with 8 digits, and henceforth 8 into 8 into 4 will be the correct answer. Sandeep, I just explained once again. Okay, are you asking the complete question? Great. So question says, how many different 3-digit numbers can be formed so that the units place of the 3-digit number is always prime? So nowhere it has been specified that I can use which digits. So all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 as well as 9 will be available to us. Now we have a condition here that the units place of the 3-digit number is always prime. So I need to first figure out how many prime digits are there. 2 is prime, 3 is prime, 5 is prime, so as 7 is prime. So I need to form a 3-digit number where units place should have a prime digit. So there is a condition attached at the rightmost position. So the question will be solved this way, that you need to fill the condition first and then proceed from left to right. A part says repetition of the digits is allowed. So we need to form a 3-digit number. So we'll be making 3 dashes. The condition attaches at this position that it should have only prime digit. So I have already figured out that we can use any of the 4 digits out here which are prime. So I'll be filling 4 out here because I can fill only prime digits here. Now we need to proceed from left to right. At the leftmost position, I can fill any of the 10 digits, but obviously 0 cannot turn up at the first place. So 0 will be out and I'll be left over with 9 digits. At the second place, I can now write any of the 10 digits because repetition is allowed. So I can fill the first place and the second place and the third place, and the final answer will be 360. Clear about it? In the B part, it says repetition of the digits is not allowed. So I need to form a 3-digit number. So we'll be making 3 dashes. The condition attaches that the units place should have a prime digit. So we know there are 4 prime digits, so I can write any of the 4 digits out here. Now, in this scenario, in the B part, repetition is not allowed. That means whatever digit I have used here, I cannot write it again. So let's assume that 5 is the digit which I have used at the rightmost position. At the first place now, 0 cannot turn up as well as 5 cannot turn up because it has been already used at the rightmost position. So at the leftmost position, if 0 cannot turn up, 5 cannot turn up, that means 2 of the digits cannot turn up. There were 10 in total available to us, 2 cannot turn up. That way means I'll be left over with 8 digits which I can fill out here. Overall, in this question till now, what we have done is I have used one of the digit at the rightmost position. I have used one of the digit at the leftmost position. So there were 10 digits available. I have used one digit out here, one digit out here. So that means I have used two of the digits. So at the second position, I'll be left over with any of the 8 digits which I can fill. I need to fill the first place and the second place and the third place. So the product 884, which is 256, will be the correct answer to the second part. Clear about the idea? Great. Quickly note down the idea and then we'll move on. Okay, guys, moving on now. Sorry, just a second. Now the next idea is arrangement of letters or things. Herein we'll be simply using a particular formula to relate out the idea altogether. Simply remember, n different things can be arranged on a straight line in n factorial ways. And secondly, n different things on a circular pattern can be arranged in n minus 1 factorial ways. N different things can be arranged on a straight line in n factorial ways, whereas n different things can be arranged on a circular pattern in n minus 1 factorial ways. Note down these 2 points. It's an important idea. Think about it and let me know, why are we subtracting 1 in the second case? Why not 2? Why not 3? What is the whole idea and the objective about n factorial and n minus 1 factorial? Think about it and answer. I'm waiting for your reply. So guys, open your mic and speak. Why is it so that n different things can be arranged in a straight line in n factorial ways and n different things can be arranged in a circular pattern in n minus 1 factorial ways? Let me be very honest, because starting and ending each same point, maybe rotation. So Sandeep, starting and ending point is same, so we subtract 1. Why so? Okay, you are saying same 1 is repeating, that's why. No, no, no. Maybe rotation. Tanuja, can you explain a bit more what are you saying with regards to rotation as the word? The same thing as Sandeep said? Okay, no idea. Okay, are you guys clear about my question, what I'm trying to ask? Why it is on the straight line n factorial and why it is n minus 1 in case of circular pattern? That's my question. Today I think Jyoti is sleeping, right? She's not answering at all. Then no idea. Okay. Okay, guys. The idea is also very simple. N different things can be arranged in a straight line in n factorial ways. Why is it so? Simply understand this way. If let's say I'm arranging 3 things on the straight line, so it's quite obvious that I'll be making dashes like this because I'm arranging 3 things. So I'll be making 3 dashes. So let's say there are 3 chairs and 3 students needed to be seated on that. So at the first position, I can place any of the 3 students. Now 1 is sitting on this chair. So at the second position, I'll be placing any of the leftover 2. And at the third position, I'll be placing the leftover 1. I need to fill the first position and the second position and the third position. So the product 3 to 1 will relate to the idea of 3 factorial, which is basically there were 3 things to be arranged on a straight line in 3 factorial ways. So simply n different things will always be arranged on a straight line in n factorial ways. But let's say I'm arranging things on a circular pattern. So let's say 1, 2, 3, 4, 5 seats are there and there are 5 people which are to be seated on these 5 chairs. Now, the point arises on a circular pattern, which one is the first position? Now here we have already concluded we will always proceed from left to right. So we know this is the first position, this is the second position, this is the third position. But on circular pattern, there is no left to right. So we cannot conclude which one is going to be the first position. So that means we need to fix one of the position at first and then arrange the leftovers. So whatever we are going to fix, we cannot arrange that anymore. And if we cannot arrange that anymore, that needs to be out of the arrangements. And that is why we are subtracting 1 out of the arrangements. So if there are 5 things to be arranged on a straight line, 1 will be fixed and rest over 4 things will be arranged. So that will make out 5 minus 1 factorial, which is going to be 4 factorial as the correct answer. So because in a circular pattern, we don't have any fixed position as the first position. So we need to fix up any of the first position first and then leftover 4 positions will be arranged. So it can be any now. If you fix this as first, these 4 will be arranged. If you fix this as first, these 4 will be arranged. If you fix this as first, the leftover 4 will be arranged and it is always going to be the same thing. So therefore, in case of circular pattern, we have the formula n minus 1 factorial and in case of straight line, we have the formula n factorial. Does that make sense to everyone? Awesome then. Quickly note down the idea and then we'll take certain examples to understand the concept in detail. Okay, guys, moving on now. Now, let's take an example out here. It says how many different 5-letter alphabetic words can be formed using all the alphabets of the word begin. The question could have been asked this way as well. How many words with or without meaning can be formed using all the letters of the word begin? Both of the question means the same thing, but obviously the language of the question is different. So just be conscious about it. How many words with or without meaning can be formed using all the letters of the word begin? Or how many different 5-letter alphabetic words can be formed using all the alphabets of the word begin? Basically, the idea is begin has BEGIN. So basically it has 5 letters. So how many rearrangements can be formed for these 5 letters? So simply we can say 5 different things can be arranged on a straight line in 5 factorial ways, and that will become the answer to the question. Simple, straightforward. Am I clear about the question? So it's all about asking you different rearrangements of the word begin, means the letters of the word begin. So 5 different things can be arranged on a straight line in 5 factorial ways. Simply 5 factorial will become the answer to the question. Am I clear about the question here? Awesome. What you guys do now is, this will be the standard question. So you can note down this question as it is and put first part as begin. We'll be just changing the words altogether in next parts, and we'll be understanding different set of questions. So the major statement of the question will remain same. Only the word begin will change to some other word, some other word, some other word, and altogether the question as a whole will remain same. So quickly note down this idea, and then we'll talk about certain more words associated in this context. Okay guys, moving on. Now, try out this question and tell me what will be the answer. No, okay. My battery is still working, but my laptop's battery is getting charged because power has resumed. I'm about to drain, but my battery is very good. It's my personal battery, you know. I think I made a very bad joke. Nobody laughed. Now don't laugh after me saying the things. Okay, what's the answer for this question? This much time to solve this question? Guys, what is the answer? Just tell me in the factorial form only. Okay, 5 factorial. In the previous question, the word was begin, B-E-G-I-N. And in this question, the word is digit, D-I-G-I-T. So it's quite obvious 5 different things can be arranged on a straight line in 5 factorial ways. So that will be the answer. Similarly, out here, 5 different things can be arranged on a straight line in 5 factorial ways. But the point is, these two words are going to be way too different. They are not same actually. Now out here, the word was B-E-G-I-N, which is begin. If I ask you to rearrange the letters E and I, so the new word formed will be B-I-G-E-N, which is going to be different from this particular word. They are not going to be same. But in case of digit, if I ask you to arrange I and I, it will give you the word D-I-G-I-T only, which is as same as digit. That means there is no difference out here. So we need to remove that duplicacy. And we have already discussed this fact that if things are repeating, then we need to divide with those many factorials with which, in the case of digit, there are 5 things to be arranged in a straight line. 1, 2, 3, 4, 5. So 5 different things can be arranged on a straight line in 5 factorial ways. But out here, 2 i's are repeating. So if 2 i's are repeating, then we need to divide our answer with 2 factorial. And henceforth, the correct answer to this question will become 5 factorial divided by 2 factorial. So simply remember this way, that whatever is repeating, we need to divide with those many factorials with which the things are repeating. Am I clear about this? Awesome. So for digit, the answer will be 5 factorial by 2 factorial. Similarly, moving on to the next example. Now, what will be the answer out here for the word Nitin? Okay. Out here, n different things can be arranged on a straight line in n factorial ways. So 5 different things, 1, 2, 3, 4, 5. 5 different things can be arranged on a straight line in 5 factorial ways. But out here, 2 n's are repeating. So we'll be dividing our answer with 2 factorial. And simultaneously, 2 i's are also repeating. So we will be dividing with 2 more factorial for the repetition of 2 n's as well as 2 i's. And that will become the correct answer to the question. So basically the point is, whatever is repeating, we need to divide with those many factorials with which the things are repeating separately. So we cannot say in this case that it will be 5 factorial by 4 factorial. That will go wrong because 4 n's are not repeating, so as 4 i's are not repeating. 2 n's are repeating and separately 2 i's are repeating. So we will be dividing 2 factorial for 2 n and 2 factorial separately for 2 i's. Am I clear about it? Awesome. Moving on to the next example. What will be the answer out here? We have 11 alphabets here for the word mathematics. What will be the answer? So simply no need to type. It's going to be very lengthy. So I'll be writing the answer. 11 different things can be arranged on a straight line in 11 factorial ways, wherein 2 m's are repeating, so as 2 a's are repeating, and then finally 2 t's are repeating. So for 2 m's, we'll be dividing with 2 factorial. For 2 a's, we'll be dividing with 2 factorial, and for 2 t's, we'll be dividing for 2 factorial, and this will become the answer to the question. Am I clear about it? Okay. Last final question for the day. How many words with or without meaning can be formed with all the letters of the word equation? So what will be the answer for this word? Yes, please. What's the answer for this question? No, Bikrant, it will be 8 factorial, not just 8. Okay. So there is a deliberate reasoning out here for discussing this particular question. The point is, if things are repeating, then only we are going to divide with something. If things are not repeating, it's not mandatory to divide at all. So simply 8 factorial will become the answer in this situation. So 8 different things can be arranged on a straight line in 8 factorial ways, and that will become the answer out here. Simple, straightforward. So out here, the basics are over. Now, tomorrow we will be talking about questions in which some conditions are attached with it. And finally, we will be doing questions from the handout. If by chance you get the time, please do attempt the questions from the handout so that it becomes easy for us to discuss in the class. Okay, then that's all for the day. Thanks a lot for joining in, guys. Have a very, very good night. Just be safe and take care. See you guys tomorrow, same time. Good night. Bye-bye. Take care.